Let's talk about everything that pertains to factoring. So first off, let's go over the basis of factoring. Factoring means to write as a product. So for example, if we had the value of 30, 30 can be rewritten as two factors of 6 times 5. And 6 can also be rewritten as 2 times 3. So writing the number 30 as factored would be 2 times 3 times 5. Now if we had a quadratic equation, you can factor that into x plus 2 times x plus 3. And you would always want to check your answer when you factor. So we can have x plus 2 times x plus 3. We would multiply that out, and we would have x squared plus 3x plus 2x plus 6. And when we simplify that, we would get our original problem of x squared plus 5x plus 6. Now in this video, we are going to learn how to do that. First off, let's go over some terminology. So these two right here, x plus 2 and x plus 3, those are considered factors. They are multiplied against each other. Those are both factors. Now in our bottom equation down here, when you're adding two things, that would be considered a term. So x squared and 5x and 6 are all considered terms. So keep that in mind as we go forward. So the first step with learning about factoring is figuring out how to find the greatest common factor. Now the greatest common factor is the largest thing that divides each term. So for our first example, when we're factoring 15 plus 25x, our greatest common factor would be 5. And so if we pulled out that greatest common factor, we would have 5 times 3 plus 5x, and that would be factored using the greatest common factor. With the second problem, our greatest common factor would be x squared times y. And so if we pulled that out, we would have x squared times y times 1 plus xy. And we can check that answer by multiplying that through. So we would have x squared y times 1 plus x squared y times xy. And if we simplify that, we would get our original problem of x squared times y plus y squared times x cubed. And so that wraps up the greatest common factor. Now we're going to talk about factoring by grouping. So with this, you want to look for problems that have 4 terms. And in this case, we do. So you're going to group the first two and the last two together. And now you're going to factor those two sets individually. So if we factor x squared out of x cubed plus 3x squared, we would have x squared times x plus 3. And then on the second half of our equation, we can factor out 4. So we'd have 4 times x plus 3. And now if you notice here, we have an x plus 3 in both sides, which means that's a common factor. So if we pull that out, we would have a remainder of x squared plus 4, and that would look like this. And that's how factoring by grouping works. It's useful if you have 4 terms, so always keep an eye out for that. Now let's address how to factor quadratics. So when you factor a quadratic, it's going to end up in a form like this. You're going to have an x plus or minus a number times x plus or minus a number. And so how we're going to do this is we're going to find a value that when multiplied equals 8. So 8 is our value here. When it's multiplied, it equals 8, and when it adds up, it equals negative 6. So in order to find those two values, we need to factor 8. So if we factor 8, we would have 1 and 8, we would have 2 and 4, negative 1, negative 8, and negative 2, negative 4. And now if you notice, if you add negative 2 and negative 4, that would be equal to negative 6. So the numbers we would want to work with here are negative 2 and negative 4. And now all we do is write them in place of our missing spaces. So the factor of this problem would be x minus 2 times x minus 4. A final thing to do with quadratics that's useful is to check your answer. It's always important to check your answer to make sure you factored it correctly. So in this case, when we multiply out, we would get x squared minus 4x minus 2x plus 8. And when you simplify our 4x and negative 2x, we would get our original answer of x squared minus 6x plus 8. Now the next problem, we are actually going to want to use factoring by grouping. And how we're going to do that is we need to set up this equation so that it can be factored by grouping. Sometimes it is useful to use an X like this to see the numbers you're going to deal with. So how we're going to do this is we're going to multiply our leading coefficient, which is 10, by our -6 value. And when we do that, we're going to get a -60. And then we're going to take our 11 value here, and we'll put that at the bottom of our X. Now what we want to do, like previously up here, we want to find a value that when multiplied equals -60, and when added equals 12. And so first we're going to factor -60. The factors of -60 would be -1 and 60, -2 and 30, -3 and 20, -4 and 15. Now we can stop right there and recognize that -4 and 15 would add up to 11. So now we are going to rewrite our equation by replacing 11x with -4x and positive 15x. So that would look like this. We would have 10x squared minus 4x plus 15x minus 6. And now you can see how that is useful, because we can now factor by grouping because we have 4 terms. And we can recognize that -4x and plus 15x is equivalent to 11x. So we didn't change the equation, we just made it easier to factor. So if we factored this by grouping, we would have 2x times 5x minus 2 plus 3 times 5x minus 2. And again, like our other problem, 5x minus 2 is common with both sides. So if we simplify this further, we would have 2x plus 3 times 5x minus 2. Now let's go over difference of squares. So if we had a squared minus b squared, the formula states that would be equal to a plus b times a minus b. Let's go ahead and confirm that. So if we check that, a plus b times a minus b would be equal to a squared minus ab plus ab minus b squared. And so our two ab's would end up canceling, which would leave us with a squared minus b squared. So with this first problem, we can rewrite our x squared minus 16 as x squared minus 4 squared. 16 can be rewritten as 4 squared, and now we can apply our difference of squares formula, which would leave us with the answer of x plus 4 times x minus 4. Now our next problem can be rewritten as 3p squared minus 1 squared. And so again, we apply the difference of squares formula, and that would be equal to 3p plus 1 times 3p minus 1. Now we need to be aware of the fact that sum of squares formula does not exist. X squared plus 4, there is no perfect formula for that. This only applies to the difference of squares, like x squared minus 4 squared. Let's talk about the difference or sum of cubes. There is a formula for both the difference and sum of cubes. So if we had a cubed minus b cubed, that would be equal to a minus b times a squared plus ab plus b squared. And with a cubed plus b cubed, that would be equal to a plus b times a squared minus ab plus b squared. So with this problem here, we're going to factor y cubed plus 27. Now 27 can be rewritten as 3 cubed. So our new equation would be y cubed plus 3 cubed, and so we can use the sum of cubes formula, which would be equal to y plus 3 times y squared minus y times 3 plus 3 squared. And so if we simplify that, we can combine our y and 3 together, and 3 cubed would be equal to 9. And so that wraps up factoring. So in this video, we talked about factoring the greatest common factor. We covered factoring by grouping, factoring by quadratics, factoring the difference of squares, as well as the difference or sum of squares. So if you have any questions, please comment down below. Otherwise, thank you for watching.